Hello, in this video we are going to look at the oh so wonderful L'Hopital's rule. L'Hopital's rule is a technique that is used to help us find limits easier, but it only applies in certain situations. Therefore, we first need to talk about indeterminate forms before we can introduce L'Hopital's rule, because L'Hopital's rule is only going to apply to these types of indeterminate forms. But it is wonderful, and students love L'Hopital's rule. I love L'Hopital's rule because it makes limits much quicker. Okay, so let's talk about indeterminate forms first. So we have this limit as x approaches -1. And if I try direct substitution, because that's what we always try first, we get 2 times 1 minus 2 over -1 plus 1, which is 0 over 0. And that's a problem, okay? We said we don't know what that answer is. So we can use algebraic techniques to try and simplify this. The first one here is doing a little bit of factoring. So I have this, and then that factors as x minus 1 over x plus 1. So therefore my x plus 1 will cancel, giving me the limit as x approaches -1 of 2 times x minus 1. Now I can do direct substitution, and it's 2 times -2, which is -4. Okay, so that was our limit, and we solved that with algebraic techniques. So we got stuck at this 0 over 0, but then we could use algebraic techniques to solve it. Okay, the second one. If I plug in infinity, well, I basically have infinity over infinity. Okay, if I try a sort of direct substitution for the x there. Now, what is that? I don't know, is it infinity or 0? Well, using algebraic techniques, or this case, it's more intuition, with our laws of horizontal asymptotes, because we know that if we're looking at a limit as x goes to infinity, really, we're asking ourselves, where are the horizontal asymptotes on this equation? So because the degree of the top and the bottom are the same, that means the horizontal asymptote occurs at the ratio of the lead coefficients. So therefore this asymptote is at 3 over 2. Okay, and then this other one, limit as x approaches 0, gives us e to the 0th minus 1 over 0. E to the 0 is 1, and that is 0 divided by 0. So I don't know the actual value of this limit. But the problem is with this one, with this equation, I don't have any algebraic techniques that I can use to help simplify it. I need something else. Okay, now I showed all of these examples because they are all examples of indeterminate forms. And so now I'm going to go back and explain that a little more. Why is 0 divided by 0 indeterminate? Like we cannot determine it. Because this is not 0, like the number divided by 0. It's a limit, okay? So both of these are limits as something is approaching 0. So you think about it, if the top approaches 0 first, then 0 divided by something is equal to 0. But what if, in a sense, you think about the bottom reaches 0 first? Well, then a number divided by 0 is always undefined or does not exist. We would say the limit does not exist. So in the case of the bottom reaching 0 first, it's undefined. But in the case of the top reaching 0 first, it would all equal 0. So which is it? We're not sure. Same idea applies with this infinity divided by infinity. Same idea applies for this infinity divided by infinity. If the top reaches infinity first, well, in that case, we would have infinity. Because infinity divided by anything is still infinity. It's still so big. But if the bottom reaches infinity first, well then any number divided by infinity is going to equal 0. Because you think about taking some number and dividing by something really, really big. Okay, so I don't know, is the answer to this limit infinity or 0? And then once again we have that 0 over 0 for the third one, which again, does that equal 0 or is it undefined? So we call these indeterminate forms. And there's a whole bunch of indeterminate forms when involving limits. We've got the two we saw, infinity divided by infinity, and then 0 divided by 0. But we also have infinity minus infinity. We have 0 times infinity. we have 0 to the 0th, 1 to the infinity, and then we have infinity to the 0 power. So all of those are when you're taking a limit as x approaches some number of a couple functions. And if one function goes to 0 and the other to 0, it's indeterminate. So each of these are talking about limits of functions. And those are various forms of indeterminate functions. And we're going to look at the ways to attack each of those forms. Today we're going to look at the most basic ones of 0 divided by 0 and infinity divided by infinity. And when a limit is of that form, you are able to apply L'Hopital's rule. So the question is, what is L'Hopital's rule? And here it is. L'Hopital's rule, the wonderful, wonderful L'Hopital's rule. So useful. Let f and g be functions that are differentiable on the open interval a to b containing c except possibly at c itself. So maybe not differentiable there. Assume that g prime of x does not equal 0 for all x in the interval, except maybe at c. If the limit of f of x divided by g of x as x approaches c produces the indeterminate form of 0 divided by 0 or infinity divided by infinity, then we can say this, and here's the rule. The limit as x approaches c of the function divided by the function is equal to the limit as x approaches c of the derivative divided by the derivative. So that is saying, instead of trying to find the limit of the functions, you can take the derivative of the top, derivative of the bottom, and then take the limit. And that usually simplifies things. But it's really important. You can only apply L'Hopital's rule if the original limit is an indeterminate of this form, 0 divided by 0 or infinity divided by infinity. You cannot just go applying it to every single limit. You will get yourself in trouble. You need to only apply it to these indeterminate forms. So let's see how this works. I put here the 3 problems that we looked at right at the start. So we know the answer to the first 2. But does L'Hopital's rule give us the same answer? So the first thing you do if you want to use L'Hopital's is you have to try direct substitution and see if it's an indeterminate. So if I plug in -1, you got 0 over 0. Okay, that means we can do L'Hopital's. So we're going to say the limit as x approaches -1 of our function is actually equal to the limit as x approaches -1 of 4x over 1. So what did I do? I took the derivative of this individually. Okay, it's not a quotient rule. I just took each derivative individually. And a derivative of this, and then that's my new limit. Okay? Now, here's a little notation thing. If you apply L'Hopital's rule, it's common to put a little L there standing for L'Hopital's. Because if you think about it, technically, this does not equal that. So we can't just have an equal sign because they're not the same. I took the derivative between them. But when I apply this little L symbolizing L'Hopital's rule, it's kind of showing that's why I drew that equal sign, because I applied the rule. So anytime you do L'Hopital's, put that L through the equal sign. Now I take the limit and I do it with direct substitution. So 4 times -1 over 1 is equal to -4. That's my answer. Same as before. Okay, I'll go through and try that second one now. So limit as x approaches infinity of 3x squared minus 1 over 2x squared plus 1 equals. Well, first, let's check. If I plug in infinity, I get infinity. If I plug it in the bottom, infinity. Okay, it's indeterminate, so I can apply L'Hopital's. So this equals, put my little L for doing L'Hopital's, it equals the limit as x approaches infinity of 6x over 4x. But notice here, if I do direct substitution, I still get infinity over infinity. So I'm still stuck. Oh, but this is still an indeterminate form. So guess what? You can apply L'Hopital's rule a second time. You can apply it as many times as you need, so long as it continues to be in indeterminate form. So now if I do the derivative of the top, it's 6, and derivative of the bottom is 4. Direct substitution, well, it's still 6/4, which equals 3 over 2. Hey, same as we got last time, once again. Okay, now we'll try this last one here. This is the one that we couldn't do before because we did not have the algebraic techniques to solve it. However, it is indeterminate because it's 0 over 0. So let's do L'Hopital's rule. So the limit as x approaches 0, applying L'Hopital's. Derivative of the top is 2e to the 2x. Okay, a little chain rule there. Derivative of the bottom is 1. Hey, now I can plug in 0 and I have 2 times e to the 0th over 1, which is 2 times 1, which is 2. So in this case, L'Hopital's rule allowed me to find the limit when I could not previously. Okay, and we're going to try 2 last examples to help us out here. So for this one, let's apply L'Hopital's rule and we get the limit as x approaches -3. Take the derivative of the top, derivative of the bottom, and then I can do direct substitution. So I have 1 over 4 times -3 equals 1 over -12. Wait, hold up. Did we check if this was indeterminate form? Because you must do that. So I plug in -3 and I get 0. Plug in -3 to the bottom, I have 2 times 9, which is 18, plus 1, which is 19. That's not indeterminate form. This limit is not -1/12. Okay, L'Hopital's rule gave the wrong answer because I applied it in a place that I was not supposed to. It was not indeterminate form. Okay, that's why you always do direct substitution first. So if I do direct substitution on this problem, I plug in -3, and we kind of already did this, but let's just do it for the sake. -3 plus 3 is 0 over 18 plus 1, but 0 divided by anything is 0. So the actual value of this limit is 0, not -1/12. Always do direct substitution first to be sure that you can apply L'Hopital's rule. Okay, and a final example. Plug in infinity. This is going to go to infinity slowly, but it's going to get there. And x is going to be infinity. So I can apply L'Hopital's rule. So I will take the derivative of the top and the bottom. Derivative of ln x is 1 over x. And then derivative of x is 1. And that is just equal to 1 over x. Well, the limit of this, it's basically 1 divided by infinity. But that's not indeterminate, because a number divided by infinity, number divided by something really, really big, is just 0. So we can indeed find that limit. So that is an introduction to L'Hopital's rule. But there are further versions of indeterminate forms, maybe 0 times infinity, or infinity minus infinity, that you can't directly apply L'Hopital's rule, but you can do certain algebra to that to get it into the correct indeterminate form. Maybe infinity over infinity or 0 over 0. So that is further ways to extend L'Hopital's rule, and we can talk about that in another video.